Okay, now we're going to work on something called conversions, which is how we're going to convert between turn one thing into something else. This is also sometimes called dimensional analysis, which if you're trying to Google help or maybe you've heard it in another class, and maybe given that name. So conversions are going to be a significant portion of this class because honestly, a lot of chemistry is taking a measurement in one unit and converting it to another unit that would be more useful for our problem. This is honestly what a whole lot of the first semester of general chemistry really is. Our sections, we're going to be doing things like, how do I take a gas and I measure its volume, but I want to know how many molecules are in it. Or maybe I've got a liquid, but I want to know how many molecules of dissolved medicine do I have inside that liquid. I want to give a drug to an animal, but because it's something I'm treating, I'm a vet. And I need to know how many molecules I'm giving it. So I got to figure out if I've got 100 milliliters of this stuff, how many molecules are there to get into the cells of this animal, and maybe I have to compare that to the weight of the animal. So I'm going to want to use units to convert from the initial volume and the concentration of that into whatever is going to be more useful to talk about what's actually getting into my animal. Anytime I have an equality between two different units, I'm going to be able to use that as a conversion. So for example, if I know that 1,000 millimeters equals 1 meter, that means anytime I have millimeters, I can change it into meters. And anytime I have meters, I can change it into millimeters. We're going to do this by writing them as conversion factors. These are going to be written as fractions. So for example, I could write 1,000 millimeters over 1 meter, which is equal to 1 meter over 1,000 millimeters. The important thing is because these numbers are the same thing, they're always equal to 1. It's kind of like you could imagine if you had a dozen of something, that's the same as having 12 of that thing. So let's call them donuts. So if I had a dozen donuts, that's the same thing as having 12 donuts. So if I were to divide, okay, that donut is misspelled. I know donut doesn't have an E. I'm not that bad at spelling. Just stop it. Okay, so if I took 1 dozen donuts and divided it by 12, well, that's 12 divided by 12, and we know that's equal to 1. Now, we do a lot with units attached to things. You'll see this used a lot, and this ends up being really helpful. It means we can multiply anything by this fraction, and it doesn't change anything because they're equal to 1. So when you have a number, you can multiply it by this conversion factor, and it won't change anything in terms of the number. It will change the unit because we've got to work those out. The millimeters and meters don't just disappear. So let's look and see what this looks like. So let's say I want to change 3.25 meters into millimeters. How would I do that? Well, first, I got to get a conversion factor that's useful to me. So I know that 1,000 millimeters is equal to a meter, which I can write as this fraction, 1,000 millimeters over a meter. So I take that, I take my information that I'm given, that's supposed to be an underline, I'm not trying to cross it out, which is my 3.25 meters. That's this right here. I multiply it by my conversion factor. And I have this S later because eventually you'll multiply by multiple conversion factors at the same time. And we'll get our new unit. The reason this works is I take the number 3.25 meters and I multiply it by a fraction, 1,000 millimeters over a meter. It's going to equal 3,250 is the numeric number, but the meters cancel. One's in the numerator, one's in the denominator. This is much like in math class. If meters was X and millimeters was Y, well, the two X's, one's on the numerator, one's denominator, they can cancel, and then I'm left with a Y, which is millimeters. So in this case, even though 3.25 and 3,250 as numbers are different, when I put the units on them, they're the same thing. So 3.25 meters is the exact same thing as 3,250 millimeters. I also want to point out that the way I'm going to write this fraction thing sometimes is going to look like this. So if I have 3.25 meters, I like drawing these crossbar things where I keep track of things, where I have 1 meter on bottom and 1,000 millimeters on top. And then I cross these out and it's equal to 3,250. The idea behind this is each of these little bars where they meet, that just represents a multiplication sign where I'm putting the top and bottom of my fraction. I mention this because this is how I learned how to do chemistry, so I'm going to write them like this, but they mean the same thing. I find this bar version works really nicely when you start having 4, 5, 6 conversions in the same problem, which sounds really scary at first, but as you get practiced at them, they get more second nature and it's easier to do a couple at the same time. And I just like this way of writing it. You can write it as this multiplication by fractions as well. They both mean the same thing. We can also do this in reverse. Let's say I had 3,250 millimeters. We said when we were learning conversion factors that the fractions worked both ways. So I can multiply it by 1,000 millimeters over with 1 meter on top. The millimeters cancel, and it becomes 3.25 meters. You'll notice I put the unit I want to cancel on the bottom because the unit I already have is in the top and I need them to cancel. That's how I knew to put millimeters on bottom. I didn't memorize, oh, always put millimeters on bottom, because that's not true. In the top version, we put it on top. I'm just going to put the unit in the denominator that I want to cancel with the unit in the numerator. And then the answer I'm looking for, well, that occurs in the top then. So it's important to pay attention to the units here. If the unit appears in the numerator of one fraction and denominator of another, you can cancel them out. You can't just make them go away without doing that, though. You can't not pay attention. So for example, if you had said 3,250 millimeters times, and you made a mistake and you said, oh, 1,000 millimeters over 1 meter, well, now both millimeters are in the numerator. They don't cancel anymore. Technically, this gives you millimeters squared over meters, which is a unit that doesn't really mean anything. So you need to check and make sure, rather than just, it's easy to go, I'm not going to pay attention to units, it's fine. Multiply it by 1,000, I got the right answer. It's in meters. But you have to make sure that they're in the right place to be able to cancel, and that's what makes these things work. Yeah, so you can think of it like algebra, where you have the variable x. The difference is, and this is true for a lot of chemistry, we're just going to change what x looks like. Rather than using x and y, like you did in algebra class, we're going to use a lot of symbols like kilometers or milliliters or grams. Then when you start solving things, we'll have volume is v, or area is a, or maybe a molarity is a new term we're going to learn in a while. It'll have a capital M. So we'll have a bunch of different terms, but they're basically just, they can treat them like variables like we did there. So think of them like that when you're doing your conversions. You have to keep track of them, and they can cancel each other out as long as you obey your math rules with them. So how do we solve problems like this? So let's say Brooklyn wants to measure out 2.4 kilograms of material, and she has a scale that shows mass in grams. How many grams will Brooklyn need to measure out? So step one is we identify our starting information. So what we know is we have 2.40 kilograms. And sometimes when I'm first doing problems, I like to even do that. Like I'll like circle the material I'm working on. Or if you're working on a computer screen like you may be this semester, y'all like hand write down, okay, 2.4 kilograms. My second step is I need to know, what is the question asking? How many grams? So that's what I want to find. And then, how am I going to try to get there? Now, depending on how comfortable you are with conversions, this step may not feel very necessary. You're like, oh, I know how to convert a kilogram and a gram. As problems get more complicated, though, sometimes you're going to look and go, I have no idea how to get there. So it can help to try to work out what types of things you could do before you start trying to jam numbers in a calculator and just solve the problem. So what I know is I want to go, I didn't mean to make that disappear. I want to go from kilograms to grams. And I know that 1 kilogram is 1,000 grams. So therefore, I can use that as a conversion factor. And I'm only going to need one step, that means. So if we start with our 2.40 kilograms, and we convert it, we need 1 kilogram on bottom because we need it to cancel with the unit on top. We get 1,000 grams up here. So our kilograms will cancel. And then we multiply those together. And when I do that, I'm going to get, well, first I'll write 2,400, but I need to write 3 sig figs. So I'll write this as 2.40 times 10 to the third grams, not kilograms. So there we go. So that's how I got there. I used my 1 kilogram on bottom, my 1,000 grams on top, put it in my calculator. It said 2,400, and I had to write it with 3 sig figs because there were 3 in the starting information, and remember the conversion factor counts as infinite, so we're limited to 3 significant figures. So 2.40 times 10 to the 3 grams. So now, I'd like you to try a practice problem. I want you to try to figure out how many milligrams are there in 125 grams. Try solving that. So pause it here. Now, hopefully you've worked this out. So with our problem, we're going to find that we know there are 125 grams. We want to find how many milligrams there are. And we know that there are 1,000 milligrams in 1 gram. So if I write that out, 125 grams, if I have 1 gram, it's equal to 1,000 milligrams. So it's out. And then when I put that in, I'm going to get 125,000 milligrams, which you can write like that. That's an okay answer. But I also like saying 1.25 times 10 to the 5th milligrams. I find that just, it looks more reasonable. And as you start getting lots of zeros, it becomes unwieldy. And in a multiple choice problem, you should be able to tell either of those is the right answer. That's an important step along the way.